The ideal condition for most vessels is upright and slightly trimmed by the stern. Most vessels and shipboard equipment operate best in this upright and slightly trimmed by the stern condition. Also, an upright vessel provides equal resistance to forces like wind and waves from any direction. Most of the time the sea is not calm and mirror-like as shown in this picture. The more realistic scenario is a vessel moving in a seaway. The extent and type of motion depends on the period, height and direction of the wind, waves and the swell. There are 6 motions made by ships. They are: rolling. This is most common motion. It is rotational when the port side rises, when the starboard side falls, and vice versa, alternatively swaying. This the brief sideways motion of the whole vessel to port or starboard along the slope of the sea surface. Pitch. This is when the stern rises when the bow falls, and vice versa, alternatively. Surging. This is the brief forward motion of the whole vessel along the slope of the sea surface. Yawing. This is the momentary deflection from projected course, when the stern moves to port, when the bow moves to starboard, and vice versa, alternatively. Heave. This is the brief vertical motion of the whole vessel upward and downward due to the rise and fall of the sea surface. Some kind of stability is needed to react to all of these motions. All are named in the slide, but we will focus on rolling. Vessels are subjected to the greatest movement when rolling. Transverse stability associated with rolling can ensure the vessel does not capsize. Transverse stability is largely controlled by the proper distribution of weights on board. Before we introduce Metacentre, we will recap a relevant part of the previous module. We saw that the upward force is called the force of buoyancy and acts vertically through the center of buoyancy. The center of buoyancy is the geometric center of volume of the underwater part of the hull. As the vessel is heeled, the shape of its underwater volume is changed. This causes the center of buoyancy to move off the center line. We learned in Stability for Boatmasters 1 that, in stability equations and diagrams, delta represents displacement, B represents the resultant force of buoyancy, and G represents the resultant force of gravity. In this module we will add M that will represent the initial Metacentre. Let's have a close look at this diagram. The first waterline, well, is the horizontal one, when the ship is upright, and B, the center of buoyancy is on the ship's center line. Instead of drawing the ship tilted 3 degrees to the right, we can show that by moving the waterline to WL1, and correspondingly B will move to the new center of the underwater hull at B1. When we draw a line vertically up from B1, it crosses the ship's center line at M. We show the ship tilted 6 degrees to the right, by moving the waterline to WL2, and correspondingly B1 moved to the new center of the underwater hull at B2. When we draw a line vertically up from B2, it crosses the ship's center line at the same point M. Finally we show the ship tilted 9 degrees to the right, by moving the waterline to WL3, and correspondingly B2 moved to the new center of the underwater hull at B3. When we draw a line vertically up from B3, it crosses the ship's center line again at the same point M. For small angles of heel, typically up to about 10 degrees, consecutive lines of buoyancy will cross the center line at the same point. This point is called the initial Metacentre, M. We have just seen that the position of M is dependent of the position of B. The position of B is determined by the vessel's draft and shape of the submerged portion of the hull. Transverse stability is also associated with the vertical position of the center of gravity, G, of the vessel. The position of G is determined by the distribution of weights on board the vessel. The position of G in relation to M is crucial. The vertical distance between G and M is the Metacentric Height, GM. GM represents the vertical distance between G and M. GM is a measure of initial stability. Transverse stability is largely controlled by the relationship between G and the vessel's transverse Metacentre, M.